Hello everyone. Today is the fifth day of Leetcode 75 challenge. Let's begin with the fifth question. Question 345 refers vowels of a string, and the level of the problem is easy. I will request you to read the question beforehand, as I will deep dive into the PPT and explain it in a simpler way. Okay. Now let's understand the problem in easiest way possible. So you are given a string S, and you need to reverse the vowels in the string. Vowels. Fine. You have to swap their positions. First vowel with the last, and second with the second last, and so on. The vowels, what are the vowels? Vowels are A, E, I, O, U, both uppercase and lowercase. Other characters remain the same, only vowels positions can change, and we have to return the modified string. Let us understand the problem constraints now. The length of the string would be from 1 through 3 into 10 to the power 5, and S consists of printable ASCII characters. Let's understand the input output of the problem. What is the input given? Ice cream. Output is S cream, basically. So, what they have done here is this is a vowel, this is the vowel, this is another vowel, and this is another vowel. Okay, what is the output? A, then here is the another vowel. Okay, so what we can see is that we have swapped this vowel with this vowel and this vowel with this vowel, and we got this as the output. As the vowel in S are I, E, E, A. On reversing the vowels, it becomes A, C, E, C, R, E, I, N. Okay, now let's understand this problem also. Vowels are here E, E, O, and E. Fine. Output is L, E, O, E, and E. So what we can see here is that this swap this one and this one. Okay, this one and this one, E and O. So we get O and E. So we got Leod seed basically, if you pronounce it that way. So this is the input and output of the problem. To understand what problem is asking, we should build up an intuition to the problem. Imagine you have a necklace with the different types of beads. Now, some of these beads are special, let it be A, E, I, O, U, while others are regular. Now, you want to swap only special beads without moving the regular ones. Okay, so what we're going to do to achieve this target, right? We have to swap the beads from the first and the last in a necklace, right? So, what we're going to do now? Let's understand that. We will identify all the special bits in the necklace. Okay, and sense. Swap the first special bit with the last, the second last with the last one, and so on. Understandable. Now we'll leave all the other bits in the original places. Now once all swaps are done, you get a new necklace with only the vowels rearranged. This is exactly how we reverse the vowels in a string while keeping all the characters in place. This is the necklace as per my intuition. Let these be the vowels. Now this vowel will get swapped with this vowel, and this vowel will get swapped with this vowel. In this case, these are beads. So this logic we will apply in our case. Now, since we get the intuition of the problem, let's look into the approach, how we're going to solve it. So what is the first thing that comes to our mind? We have to convert the string into a list. Why? Since we are coding in Python, strings are immutable, so we cannot change it directly, right? So we have to convert it into a list to modify the characters easily. Understandable. So the hello string is given here. We cannot just modify in Python directly because it's a string, it's immutable, it's its property. So what we do, we convert it to a string, which is HELLO in an array format. Okay, so this is the first thing we solve out. We have to convert a string into a list so that we can go further with our problem. Now, the computer doesn't know which are the vowels, or the code does not know which is the vowels, right? So we want to understand why we want to understand or make the code understand which are the vowels. For that, we will create a string which consists of smaller and capital letters both. As the question suggests, the string might have both small and capital letters included. Since you can see here, I is capital, E is smaller. Okay, this is another thing done so that we can use this string as our companion to understand whether a particular character in the string is vowel or not. Okay, now since they are saying that we have to replace the first bit and the last bit, first second bit, last second bit, right? So what could be the most optimized and most easy and understandable way? We come from back, front also, and back also. Yes. For that, what would be required? One pointer, let it be I. Another pointer, let it be J. So they will be attacking from both front and back this way. Great. So we have to use the pointers. Left pointer we starts at the beginning of the string. The right pointers that starts at the end of the string. Okay. Now what is left? We have we have the list of characters. We have a string which consists of all the vowels is all in capital, which will work as a companion while traversing the array. Third, we also have two pointers starting from first and last, which will also help us to figure out where we are right now in the array and the vowels. Now there comes the fourth part, most critical one or most important one, swapping of the vowels. If both S of I and S of R are vowels, here this L, sorry, it's not an I, it's an L, and R. L represents the left side, R represents the right side. Swap them and move both pointers inward. So what the problem is trying to say is that, let me draw it here. This is the array. If L is here and right is here, if both are vowels, let V represent vowel, we will swap them. Let this arrow represent swapping. Right after swapping, what will happen? R will come here, L will move from here, R will remove from here, and L will come here. Right, and we will increment the left pointer this side and the right pointer to the left side. Okay, if S of left is not a vowel, we move left to right, and if S of R is not a vowel, we move right to left. Okay, what does this mean? So if this is the string, right? Suppose left is here and right is here, and if left is not a vowel, N V, and this is a vowel. Since this is vowel and that is left is a not a vowel and right is a vowel, we will just increment L to the right hand side because we have to search another vowel so that we can replace the right with it, right? And if vice versa happens, if this is the vowel and this is a non-vowel word, so we will move right to the left as you have to search for a vowel from the right to the left so that we can swap this left side and the right side. So this is what is explained here. And then keep repeating it until L crosses R. And since when L is here and R is here, it means we have traversed complete array and our answer stops there. Now, now the answer asks us to return a string, right? Now, since in Python we have converted string to list, then again we have to convert list to a string so that we can return the output as a string. So we will do that by using the join keyword in the Python. I hope you understand the approach. Now let's move to the next slide. Now the code is exact copy of the approach discussed. Let's understand it line by line. First, we have a string. We stored small letters and capital letters vowels in it, which will work as a companion to us. Then we'll convert the given string to a list, as we discussed before, because strings are immutable in Python. And since we are making two pointers, we are going from left to right and right to left. We need pointer which starts from L, which starts from 0. So we make left as 0 indexed. And one pointer we want, we starts from the right. So it will be the length minus 1, the last index of the array. Now, what the code is doing here is that until and unless L is smaller or equals to R, until and unless they don't cross. If S of L is a vowel and S of R is also a vowel, pretty good. We swap them. S of L goes here and S of R goes here, right? And we increased L plus 1 and R minus 1. L plus 1 will move to the right hand side, so I plus 1 index, and R minus 1 will move to length of length of S minus 2, this side. And we will continue. If S of R is not a vowel, as we discussed, if it is not a vowel, we will just decrement the count and move to the left side. So in search of the next vowel. And if this condition is solved, and if left is not a vowel, the left index value is not a vowel, we will move to the right, finding for the next vowel so that we can swap it with R, which is the right index. After creating or after swapping all the vowels, we will use the join keyword here and return a string. Now the time complexity for the problem is O of n. Reason being, we're traversing the complete string, which will be of length n, and space complexity is O of n because we are using a list here which occupies this space, and that is the reason the space complexity comes out to be O of n. I hope you understand this code explanation. Now, since we have understanding of the code, let's look at a dry run of the example. Let's take this example itself. Ice cream. I C E C R E A and N. Okay. Let's mark the indexes 0, 1, 2, 3, 4, 5, 6, 1, 7. Okay. According to our code, we have a vowel consisting of A, E, I, O, U, A, E, I, O, U. Great. And the left index is starting from 0 and the right index here it's starting from 7. It's, and this is converted into an list. Okay. Okay. Now left is here and right is here. Is I a vowel? Yes. Is R an vowel? No. Right? But our condition says if R is not a vowel, decrement the value of R. So R comes here. Now, again we check. Is I a vowel? Or we can say if I is a vowel? Yes. Or L index value is vowel? Yes. R index value is vowel? A. Yes, it is a vowel. Right? So what we do? We swap them. It becomes A and I'm adding I here. Since M is done, let it be here. Now, what our condition says, we increment L and we decrement R. So L comes here and R comes here. Now L is C and R is E. Yes, R is the vowel, but L is not. So what we do? We increment L. Remove this. L comes here. Let me remove this. Okay. I'll remove this. Okay. Now E is also vowel, R is also vowel. We swap them. So E comes here, the R E comes here, and L E comes here. And this C will be remain intact here, so no changes. Now since both have been done, we will increment L and decrement R. And we will remove this L and this R. Again, we can see that C and R are not vowels, so we will remove this and this. R comes here and L comes here. What our condition says? Until and unless L is less than equals to R, keep it doing. Now since L and R are crossed each other, we end up our string loop here itself. So let me write the other values, right? So we can see the A C E C R E I N A C E CREIM. So we got the exact output required. Now, since we are familiar with the problem and solution, let's move to the lead code and code out the solution. We will create a vowel string A E I O U A E A E I O U. We'll convert S to a list. We will take the index L equals to 0, R equals to length of S minus 1, while L is less than equals to R if S of L in vowel, if the value consists in the vowel, and S of R is also in the vowel string. We will just swap S of L, S of R with S of L, R, and S of L. To give comma here, then we will increment as L plus 1, R minus 1, and continue. L if S of R not in vowel, R minus 1, and continue. Else we will increment the value of left side, and it will return dot join of S. So our code gets accepted. Let's submit it. So yes, we have completely solved our problem. Now, code of the problem is available in my GitHub repo. You can find the link in description. Thank you, everyone.